This is the first on the list of transformation practice problems. So the instructions that we have here are, we're given a function that's been transformed. We're asked to indicate the basic function that was being transformed, list what transformations took place, use those transformations to describe the coordinate analysis, and lastly, we'll use the coordinate analysis to sketch the graph of the transformed function, and we'll start by graphing the basic function as well. So the example here is g of x is equal to 2 plus the square root of 3 minus x. So the basic function here, the function that we're adding on to, is the square rooting function. And when we talk about what transformations took place, you're essentially looking at your basic function and asking what's been sort of added on, what's been changed. And you see that in this example, there are three things. A minus has been inserted in front of the x, a 3 has been added on after that, and then a 2 was added on the outside. We're going to think about these things in that order. So the first thing is this minus in front of the x. So say it with me if you're comfortable. This is a reflection around the y-axis, or maybe I should say about the y-axis. I want to start thinking about this already. What does the reflection about the y-axis do? Well, it takes the point and it flips it over the y-axis, which means that its y-coordinate stays the same, but its x-coordinate is reversed. So we could even say that if we're starting off with some point xy on the original function f of x, at the end of this first transformation, it'll be at negative x, y. Now the second piece, okay? So if you're looking at the square root of 3 minus x, what many of you will say is, well, you could think of this as negative x plus 3, which is true. And that plus 3 might lead you to believe that there's a shift to the left happening. But remember, we reflected about the y-axis first. And when you do that, any point that was to the right of the y-axis ends up being to the left. Any point that was to the left of the y-axis will now be to the right. So what I mean here is the roles of left and right are reversed by the reflection. So even though x plus 3 would be a shift to the left, since it's minus x plus 3, it's actually a shift to the right. So we're going to shift right 3 units. And again, this is because we chose to do the reflection first. That's kind of a rule of thumb we adopted to be consistent across all our lessons. But if you wanted, you could do this problem with the shift first, and then it would be a shift to the left, and then the reflection. So remember that this is in part because of the fact that we're doing reflections first. Kind of thinking again about our coordinate analysis, right? Coming off of the reflection, we're at negative x comma y. So when we shift to the right, every single point's x-coordinate gets increased by however many units. And what that means is that we add that many units to the x-coordinate. So since coming off of the reflection, we're at negative xy, we're going to add 3 to the x-coordinate, which will be negative x plus 3. And we still haven't done anything to the y-coordinate. If you want, you can write this as 3 minus x comma y. That probably looks a little bit nicer, but it's up to you. The last piece in our transformations list is going to address this 2 plus on the outside. So remember, this is happening on the outside, which means you've already performed the square rooting that this function does. So you're already dealing with an output, right? So, and then you add 2, which means you have a shift up 2 units. This is the first transformation we have that deals with the y coordinate. So remember, you're starting with 3 minus x comma y. And then you are lifting everybody up. And when you do that, you add that many units to the y coordinate. So this is the end of the transformations journey. You started at some point x, y on the function f of x, and then you made your way through and you ended up at 3 minus x comma y plus 2. So what I want to go ahead and do now is I want to go ahead and graph, okay? And part of the reason I always encourage you all to start by graphing the basic function is so that you have a few points to transform. Okay, so that's my y-axis, and then here is my x-axis. Okay, so then let's label them. Okay, so I hope by now the shape of the graph of f of x is pretty familiar. It goes through the origin, it goes through the point 1, 1, it goes through the point 4, 2. I say label at least 3 points, and I feel like these 3 points do a good job defining this shape. But if you want more points, if you wanted to plot 9, 3, you could do that. Okay, so let's label these. So we have 9, 3, 4, 2, 1, 1, and of course the origin. Okay, so here we are. So you've got this sort of half of a parabola. Okay, so that's f of x. Now let's think about g of x, right? So we've done the coordinate analysis already, okay? So let's use it. So if 0, 0 is our xy, what does that end up? Well, what does 3 minus x comma y plus 2 give you if x and y are both 0? It'll be 3 minus 0, 0 plus 2. By that same token, 1, 1. Well, what does 1, 1 become? If x and y are both 1, 3 minus 1 is 2, 1 plus 2 is 3. So you see I'm plugging the x and the y in to my coordinate analysis. Okay, what about 4, 2? Well, 4, 2, 3 minus 4 is negative 1, 2 plus 2 is 4. And if you want, if you're somebody who likes that extra point, 9, 3, so 3 minus 9 is negative 6, 3 plus 2 is 5. So these 4 points will morph into the blue 4 points will morph into the green 4 points. All right, so let's do it. There is 3, 2. 2, 3 is the next one. Negative 1, 4 is the next one. And finally, negative 6, 5. That's up here. Okay, so you see you have exactly, oh dear, exactly the same shape. And you can see the transformations on it. You can see that it's been reflected in the y-axis, it's been shifted horizontally to the right, and it's been lifted 2 units. You can talk about the domain and range and see what you see, but as far as the instructions for this problem are concerned, we are done. All right, that's the first. Stay tuned for the rest of them.